All right. AB Calculus AB, Unit 10, Day 10, office hours, the pretest for the test. So let's see, this is going to cover area, even problems that were even on the last test with area between multiple curves and volume. You're going to be allowed to use graphing calculators in this whole test. You have to show the setups. A lot of times I'm not even going to make you calculate the answer, but you have to show the setup. So you're not going to have to do a whole lot of integration by hand on this. And even if you could, you should probably avoid it just for time. So we're going to set up the intervals to find the area shaded by this region. Two different ways, dx. Now if we do dx, we're going to have to do vertical slices, y top minus y bottom. And we're going to have to change it right here. So we're going to have to do this chunk different than this chunk because y top minus y bottom changes. So we have, looks like all the intersections, so we don't have to find any of those. But if we needed to, we could put these in a calculator and find them, or we could just do it by hand. Now, this equation right here, we don't actually have this equation, and we don't have this equation. We have 2 points, so we're going to have to do a little bit algebra 1, find equations of lines. So the slope of this one, we do 2 minus 1 over 4 minus 6, rise over run. And so it's going to be negative 1/2. And then we do point slope form, y minus either of these equations, y minus 1 equals negative 1/2 times x minus 6. So y equals negative 1/2 x plus 3 plus 1 is plus 4. So that's the equation in that line. Equation in this line, it's going to be up 1 over 6. So the slope is positive 1/6. And the y-intercept is 0. So it's going to be y equals 1/6 x. So we have to do a little bit of work there. Find those equations. And then we have all the intersection points. So make this work clear and easy to find and follow. So let's see. Now we can start to do this. So the area dx is going to be y top minus y bottom. So square root of x minus 1/6 x dx from 0 to 4. And then we're going to go 4 to 6. And y top is going to be this line, the negative 1/2 x plus 4. Subtract this line, minus 1/6 x dx. So that's good enough for the setup. And I will want you to write the setup in the answer column. So you could do something like this, 0 to 4, square root of x minus 1/6 x dx plus 4 to 6, negative 1/2 x plus 4 minus 1/6 x dx. So you can fit it on there. Okay. And then dy is going to be horizontal slices. Now that's not going to be that much better because it's going to be x right minus x left, but it's going to change. So we're going to have to set up 2 different intervals. So we're going to do one of them. It is going to go from 0 to 1. Now x right in terms of y, that's this equation right here, would be 6y. Minus x left over here would be y squared in terms of y. dy plus 1 to 2. X right is going to be, we're going to solve that for, so you get x equals negative 1/2 x equals 4 minus y, then you're going to multiply by 2. So x equals 8 minus 2y. So x right is 8 minus 2y, and x left is y squared dy. So that's the setup. Now, you're not asked to calculate these, but if you want to, double check your answer. So we're going to put that over here too. 0 to 1, 6y minus y squared dy. Got to put the dy's, got to put the parentheses. I will take off points for all of those. Got to put the limits. You have to have these parentheses. You have to have the dy. Okay, don't leave any of that off. Now, if we want to, we could check our answers just to see. We could do math 9, square root of x minus x over 6, comma x, comma 0, comma 4, plus math 9, negative 0.5x plus 4 minus x over 6, comma x, comma 4, comma 6, just to see what we get. Should get the same thing both ways. Now, if you don't erase anything. 5.333. I bet it's 5 1/3 if you did it exactly by hand. So we tried the other one. Math 9, 6x minus x squared, comma x, comma 0, comma 1, plus math 9, 8 minus 2x minus x squared, comma x, comma 1, comma 2. Same answer. Must be right. Right? Okay. Not that you have to do that on that one. But you will, on enough of these, actually have to calculate the answer as a decimal. Hopefully you get that 100% right. Unfortunately, sometimes people get all the setups really well, and then they mess up most of the calculations. They don't know how to use their calculator or type it incorrectly. Okay, number 2, we're going to find the region of S, which is this region here. I guess any way we want. And probably vertical slices would be the best. I mean, you could try it with horizontal slices, but I don't think solving this for x in terms of y is going to be very easy. I don't think it's possible. So probably have to just stick with vertical slices, even though we're going to have to do 2 separate intervals. Now we do have to find this intersection here. We could try to do it by hand, but man, that looks like a mess. So I think this would be a great time to go ahead, and it would be good to use our calculator. 4 minus 2x x to the third divided by, you definitely need parentheses here, 1 plus x squared, window, I mean this x-intercept here, this is 0, 0, plug 0 in here, that's 4, 0, 4. So if you find these, you can get a good idea of what a good window would be. If you set y to 0, you get 2, so 2, 0. So I think we could say like negative 1 to 3, and then negative 1 to 5. Seems like a good window. So there's the line. There's the cubic. And this also, I guess, okay. So we want to find the intersection. Second calc, intersect. First curve, second curve, guess. Try and get close to it. And I'm going to write these down. So this is going to be 1 point, and I got to write more than 3 decimal places. 1.4876644, comma 1.02467112. You have to carry more than 3 decimals in the middle of your work. So I just wrote all 7 of them. Okay. So we got that on the picture. And so now we could say, okay, well, the area is going to be white. And we're going to integrate left to right. So 0 to that x, 1.4876644. And y top is just that curve right there. So it's just going to be x cubed over 1 plus x squared. And y bottom is 0. And then we're going to integrate from 1.4876644 to 2. And y top is just going to be that line, 4 minus 2x dx. So that's your setup. And we are going to calculate it as a decimal. It did say to find the area, not just set it up. So sometimes they just say set it up. So we can write this in our answer column. 0 to 1.4876644, x cubed over 1 plus x squared dx plus 1.4876644 to 2, 4 minus 2x. You definitely need parentheses around this 4 minus 2x, multiple terms, dx. Okay, and then we're going to calculate it. So let's see what we get. I wouldn't do it on the screen because you'd have to break it up and do it in separate chunks, write it down, add them up afterwards. On the home screen, you do everything at once. Now, we could take advantage of the fact that we put these in the Y menu and do the vars, Y vars thing. You just got to remember which one you did. So that's Y2. So on this screen, I could do math 9 vars, Y vars function Y2, comma x, comma 0, comma 1.48766644 plus math 9 vars, Y vars function Y1, comma x, comma 1.48766644, comma 2. And this should give us the answer. And that is the correct answer, 0.785 rounded truncated 3 decimal. Actually, I need 3 decimals only for your final answers. Rounded truncated. In the middle of your work, you need more than 3 decimals. Region R, well, we could, find, we could just do y top minus y bottom, right? And we do a single integral. So we're going to integrate from 0 to 1.48766644. And y top is going to be the line, 4 minus 2x. And y bottom is going to be this guy, cubic, x cubed over 1 plus x squared. Okay, I need parentheses around it. So that's good. That's your setup. Now this is different. This shouldn't be the same answer as the other one. So we do math 9. And we could do vars, y vars function. Y1 was the line, I think, minus vars, y vars function, vars, y vars function Y2, comma x. Just be careful, make sure you're doing things in the right order, 0. If you get a negative answer, you know you did it wrong. 1.487664. There it is. There's the answer. So 3.214 truncated or 3.215 rounded. So there you go. You write these in the answer column. 0 to 1.48766644. Whatever you write down as your work should match your answer. So you're like, well, I use more decimals than I wrote. Not good enough. Whatever you're going to enter, that should be what you wrote. Okay. So now we could have tried horizontal slicing here. It would have been more work. In fact, it would have been impossible. You're not going to be able to solve this for x in terms of y. So it's just not a good option here. Now, number 3, this is like some problems that came up on the very first day of this unit. Line y equals k divides an enclosed area into 2 parts where 3/4 of the area is below y equals k. So there's this y equals k. It's going to divide this area to where 3/4 is below, which means 1/4 is above. Now, I don't really care if they tell me what's above or below. I'm probably going to go from 0 to k instead of k to whatever this number is. This number, by the way, 4 times 36 is 144. Do you want to do 0 to k or k to 144? You want to do 0 to k. Okay. Now, if you remember, we have to find the total area to find 1/4 or 3/4 of it, and then set up another problem. Now, you could find the original area with vertical slicing if you want. Like you could say, oh, okay, well, let's just do vertical slicing. I mean, it's pretty simple. It's just area under that curve, dx, 0 to 6. You could use your calculator to find this. You don't have to. You could do it by hand, but again, that's going to take longer. So we do math 9, 4x squared, comma x, comma 0, comma 6, and we get 288. Okay, or you could do it with horizontal slicing. The next part you're going to have to do with horizontal slicing to find y equals k. This is the horizontal line. You're going to have to. So instead, you could have started with horizontal slicing because you know you're going to have to anyways. And that would be x right minus x left. So it's going to be 6 minus x left be square root both sides plus or minus. We want the positive, so it's going to be positive square root of y over 2 dy, and we're going to integrate in the y direction 0 to 144. And we can put that in our calculator. See, math 9, 6 minus the square root of x divided by 2, comma x, comma 0, comma 144. Yeah, this is taking a long time. All right, slightly different. 287.999999. Now we should be rounding truncated in the middle of our work because we need this for something else. So, I mean, I'd stick with that. Either way, though, the next part, you need to take half of that area, whichever one you want to use. I mean, it should match up to your work, right? And set it equal to an integral going 0 to k, and you have to do the horizontal slicing. 6 minus the square root of y over 2 dy. Okay. You can't do vertical slicing when you go find the spot. That's why you might go and just do the first part. Same way you're going to do the second part, just to save yourself a little bit of energy. So now it should be 1/2. It actually should be 3/4 is below the line. Or the other option is you do 1/4 of the area, and then you could do k to 144. But I personally would like to use 0 if possible. It's going to make the work a little nicer. But they should both give you the same answer. Now, 3/4 of this number is that. So I'm going to write that down, 215.9999997. Now, we have to integrate this. So it's going to be 6y minus, we have a 1/2 already, and then a y to the 3/2 divided by the new exponent multiplied by the reciprocal. 0 to k. So we're going to get 6k minus 1/3 k to the 3/2 minus 0 minus 0. Let's go away. So now we have an equation to solve, which you might be able to solve by hand, but you have a calculator. I don't think you're going to be able to solve this one by hand. So you have a graphing calculator. And so I'd move everything to one side equal to 0. That's your best strategy. That's what you would do if you're going to do it by hand. Okay. Graph one function and find its x-intercepts. And that will be the solutions to that equation. So you need to know how to solve an equation on your graphing calculator. So this is going to be 6x minus 1/3 x to the 3/2. You better put in parentheses if you can do that. Otherwise, you do 1.5. Minus 215.9999997. Type exactly in what you're writing down. That should match. My window, I expect the answer to be between 0 and 144. It's a y value. So we could say 0 to 144, and we're just concerned about trying to find the x-intercepts of this graph. So -1 to 1. And I think we should probably only get one answer. If we get more than one, or don't get one, then something's wrong. And, you know, it's probably somewhere kind of in the middle-ish right there. So second calc, 0. And this is 0 to 144, so that's probably around like 70 or so. I could say like 50 to 100, I guess 70. And so the answer is k equals 65.347. 3 decimal accurate for your final answer. Round or truncated, it comes out the same this time. That's the answer. So some different things involved in this. You got to be able to find the area. You got to be able to set up an integral with a variable in the limit that you're going to solve for. This is probably one of the only problems you actually have to integrate by hand and get the antiderivative. Okay, and then use your calculator to solve equations. So, you know, it's the setup of this. I think, you know, we'd write 0 equals 6k minus 1/3 k to 3/2 minus 215.9999997, and then the answer was 65.347. Okay. All right, volume by cross section. Now, so many of the problems on this test, you could do dx or dy, but these ones you have to do the way that it is described. So the base of a solid is bounded by this line and this parabola. That's the base, so that's your base area. Find the volume of the cross section perpendicular to the x-axis, so they got to be vertical, and they're going to be a square. Take away half of a circle. So I would just draw one slice. Okay, so the volume formula is going to be some common shape with, in terms of x. It's a square minus half of a circle. So it's going to be side squared minus 1/2 pi r squared. But we really want to get these both in terms of the same variable. So this is the side, right? Which is y top minus y bottom. And the radius would be half of that. So we could replace r with s over 2, but it all gets squared, right? Now, we're integrating the x direction, 0 to 2. So the side's y top minus y bottom in terms of x. So it's 4x minus 2x squared minus pi over 8. 4x minus 2x squared, close parentheses on the whole thing. That's your setup. You could have, before this, factored out a 1 minus pi over 8. And then you would just have, 1 minus pi over 8. And then you just have s squared inside. A little simpler. But that's up to you. 4x minus 2x squared dx. So this is a little more compact, nicely written. Now it says to find the volume, so we need to calculate this. And I would just do this on the home screen. So parentheses 1 minus pi over 8, math 9, parentheses 4x minus 2x squared, close, squared, comma x, comma 0, comma 2 is 2.591, 3 decimal accurate. So that's it. Okay, next one says find the volume of the solid if cross sections are perpendicular to the y-axis and whose in our rectangles whose height is 5 times the length of the base. So I'm going to redraw this picture real quick. It's the same base region. I feel like pictures are very valuable here, but if they're super messy, then that's not going to help. Now, if we had to, we could find these intersections on our calculator pretty easily. Let's see. So they're going to be horizontal, perpendicular to the y-axis. They're rectangles whose height is 5 times their base. So they're tall rectangles. Okay. So the volume is going to be some formula for area in terms of y, which is going to be these tall rectangles, which is going to be base times height. But they told you that the height was 5 times the base. So you're going to replace h with 5b. So it's going to be 5b squared dy. And so then the 5 could be right here. And then the base, this is the base right here. It is x right minus x left. We need to get x right in terms of y. So this is x right, this is x left. Divide by 2, square root of both sides, plus or minus. So this is going to be positive square root of y over 2, all inside the square root. And this is going to be y over 4. So square root of y over 2, x right minus x left. You always want to do right minus left. Make sure it comes out positive. Squared dy. The limits are in the y direction, 0 to 8. So that's our setup right there. And so let's go and put in our calculator. 5 math 9 parentheses square root of x over 2 close parentheses all inside the square root minus x over 4 close those parentheses squared comma x comma 0 comma 8. And it is 5.333 rounded truncated 3 decimals. Comes out the same this time. So there you go. You have some of those on your test. It's all about the setup. Okay, we're also going to have some solids of revolution that I'm going to ask you to do both ways. I might ask you to evaluate them. I might ask you to just set them up. The evaluation would just be typing it into your calculator. So let's draw a picture. Now, I think it'd be worth it to draw 2 separate pictures for each part. And on your test, I'm going to give you a lot of room to where you could easily do that. So I might try that here. So I'm going to get that. It's being spun around the x-axis. Set it up with dx. So a dx. So dx would be vertical slices, which are just going to be a simple disk. So it's going to be pi r squared dx. And so it's going to be 0 to 3. The radius is y top minus y bottom. Y bottom is 0, y top is that. It's going to be x squared dx. Okay? And then b, dy, is going to be a horizontal slice. So that's going to be parallel to the axis rotation. So it's going to give you shells. You should know that ahead of time. You should know how to find the volume of shell, 2 pi r h dy. We're going to integrate 0 to 9 in the y direction. Now the radius of a shell does not depend on the curves. It's just y top minus y bottom. Y bottom is 0. Y top is just whatever y we're at. The height of the shell, which is sideways this time, depends on the curves. X right minus x left. X right is always 3. X left, in terms of y, would be the square root of y dy. That's your setup. Now, both of these should give us the same decimal. You're not required, I guess, to necessarily do both of them. But I would do both of them just as a quick check. Also, I was running out of time. Math 9. X to the 4th, comma x, comma 0, comma 3. Two pi, math 9, x parentheses 3 minus the square root of x, close, comma x, comma 0, comma 9. Hopefully we get the same answer. Same answer. Probably means I did them right. So on your test, I want you to put the setup in the answer column. There will be a spot for it. And then there will be a separate spot for the answer. And make sure you put the parentheses and the dy's and dx's and stuff. All right. Here's another one. So we have these two curves. Now we don't actually have the equation in this line, so it's going to be up 2 over 4. So it's up 1/2. That's 1/2 x, right? Y-intercept is 0. Okay, so A is going to be dx. That'd be a vertical slice, which is also parallel to the axis of rotation. So it gives you shells. So it's going to be 2 pi r h dx. And the limits are going to be over here, always based off this, 0 to 4. the radius is x right minus x left. And it's whatever x we're at minus x left is -2. So it's going to be x plus 2. The height is the thing that depends on the curve. The curves y top minus y bottom. In terms of x, y top is the square root of x, y bottom is the 1/2 x dx. So that's your setup for shells. Okay. Part B, dy. It's going to be flat horizontal slices, which are going to be perpendicular to the axis of rotation. So you're going to get disk washers. So it's going to be pi big R squared dy for the big disk minus pi little r squared dy for the small disk. That creates the hole. So the limits are going to be the x direction, the y direction, 0 to 2. Now, big R equals x right minus x left. And x right is this x coordinate. In terms of y, is going to be 2y. Minus x left is -2 squared. The little radius is this guy right here. It's going to be x right minus x left. X right, in terms of y, is going to be y squared minus -2. So there is your setup. And we can change those to pluses if you want. And over here, we could write this pi 0 to 2 of 2y plus 2 squared dy minus pi 0 to 2 y squared plus 2 squared dy. That's the setups. And they should both give us the same answer. So let's try it out. 2 pi, math 9, parentheses, x plus 2, square root of x minus 0.5x, comma d, comma x, comma 0, comma 4. I'm going to double check it, see if they both give me the same answer. 30.159. It just might be a good thing because you might have them both perfectly set up and just type something wrong. So it might just help you catch it. If it doesn't, just put an answer. Don't not put an answer. Pi, let's see, math 9, parentheses 2x plus 2 squared, comma x, comma 0, comma 2, minus pi, math 9, parentheses, oh, I forgot the square down here. I wrote it there though. X squared plus 2, close parentheses, squared, comma x, comma 0, comma 2. All right, 30.159, same answer, 30.159, just 3 decimals for final answers. Round truncated, 3 decimal accuracy. All right, so that's that. Let's try another one. Let's try another one here. So, get a quick sketch. I'll draw the corners first. Now, A is going to be dx, so that's going to be vertical slices. So I'm going to put that over here. Just trying to get out of the way. And it's perpendicular to the axis of rotation. So it's going to be a dishwasher. So volume is going to be pi r squared dx minus pi little r squared dx. I'm going to integrate them all. The limits are going to be the x direction, 0 to 2. So the big radius is going to be y top minus y bottom. Y top is 6. Y bottom is 0. And then the little radius is also going to be y top minus y bottom. and y top is going to be 6, and y bottom is going to be the y coordinate on this curve. In terms of x is the square root of 8x squared. So that's the setup for A. dy is going to be a horizontal slice, so I'm going to try and put it right here so it doesn't cross that guy, just because that would get extra confusing. So we're going to get shells. It's perpendicular to the axis of rotation. So volume of shell, if you cut it open, 2 pi rh dy. The limits are going to be in the y direction on this original 0 to 4. The radius of a shell is going to be y top minus y bottom. It's going to be whatever y value we're at. No, it's going to be at 6 minus whatever y value we're at. So it's going to be 6 minus y. The height is right here. That's the thing that depends on the curves, x right minus x left. So it's going to be this x right, which is always 2, minus this x left. In terms of y, it's going to be y squared divided by 8, y squared over 8. So it's going to be 2 minus y squared over 8 dy. So that's our setup. So I'm going to go and put these into my calculator and see if they give me the same answer, hopefully. Pi, math 9, 36, comma x, comma 0, comma 2, minus pi, math 9, parentheses 6 minus the square root of 8x, close, close, squared, comma x, comma 0, comma 2. Taking, just relax, take a deep breath. You're waiting for your calculator to finish. Okay, either answer should be 150.796. Okay, let's try the other one. Pi, math 9, parentheses 6 minus x, 2 minus x squared divided by 8, comma x, comma 0, comma 4. Should be the same answer. Oh, shoot. Oh, I missed the 2 in front. I was covering it up with my paper. So I'm going to recopy it. Second insert 2, 150.796. Same answer. So we're going to put these setups in the answer column. Volume equals pi 0 to 2 of 36 dx minus pi 0 to 2 of 6 minus the square root of 8x squared dx. And this one is going to be 2 pi 0 to 4, 6 minus y, 2 minus y squared over 8 dy. And the answer is 150.796, 3 decimals for your final answer. Okay. Now here's another one, but this time it doesn't come with a picture. So I guess you're going to have to draw your own picture. But we are going to do it both ways. So it says first quadrant, enclosed by y equals x squared. So that's a parabola, but we know it's in the first quadrant. So we can kind of focus on over here. Okay. Y equals x plus 2. Be kind of like a line like this. It goes through 2 on the y-axis. And the y-axis, okay, so it's this region right here, only in the first quadrant. So we need to find all the intersections. This is 0, 0. This is 0, 2. This I don't really know yet, so I think we got to try and find that. Set these two guys equal to each other. X squared equals x plus 2. Move everything on one side. Equal to 0. Factor it. Now, you have a calculator, so you could do this on your calculator, but I think it's way faster to do it by hand. 2, 4. Negative 1 is over here, which we're not going to use. Negative 1 1. Now you can test it. You can check your answer. If you plug it into both of them, you should get the same thing. So -1 squared is +1. -1 plus 2 is +1. 2 squared is 4. 2 plus 2 is 4. Okay, that looks good. Now we're going to rotate around the x-axis. Now this is where the other problems, I think I drew the little rotation for you. This is what some people are going to mess up. They're going to rotate around the y instead of the x or whatever. They're going to do it the wrong rotation. So it's going to be rotated down here. Okay. And A, we're still doing dx. Now A is going to be vertical slicing. So I guess we just do it right here. So we're going to get disk washers, pi r squared dx minus pi little r squared dx. Integrate. We're integrating the x direction 0 to 2. The big radius here is y top minus y bottom. Y bottom is just 0. So it's going to be whatever the y coordinate of this is in terms of x, which was x plus 2 squared dx minus pi 0 to 2. The little radius is this guy right here. It's going to be y top minus y bottom. Y bottom 0. Y top is x squared. So that's our setup for part A. For part B, we're going to do dy, which is going to be horizontal slices. And I'm going to have to do 2 different sets. Okay? We're going to have to do a set of shells there and a set of shells here because the dimensions that affect the height are going to change. So we're going to have to do 2 pi RH dy, and then we're going to have to do another 2 pi RH dy. So we're going to have to go 2 pi, and we're going to do 0 to 2, 0 to 2, and then 2 to 4. The radius is y top minus y bottom. It's just y. It's just whatever the y value is for both of these guys. This guy's radius is the same thing. Y top minus y bottom is 0, y top is wherever y we're at. The height is where the curves come in. So this height is x right minus x left. X right minus x left. Now x left on this first one is 0. And x right, in terms of y, is the square root of y. And we go 2 to 4. Now this height right here is x right minus x left. It probably would have been helpful to draw 2 pictures. This picture is getting crazy. X right is the square root of y. Square root of both sides, plus or minus. And we positive square root of y is right half the parabola. Minus x left is going to be y minus 2. So it's going to be square root of y minus 2. Now be careful. I'd put parentheses there. And then if you want to distribute it and clean it up for a future step, then go for it. But we need to subtract that whole x left, which is y minus 2. So you have to distribute this. So that's the setup. We can go and put this in our calculator, find our answer, double check our answer. So it's going to be pi math 9 parentheses x plus 2 close parentheses squared comma x comma 0 comma 2 minus pi math 9 x to the 4th comma x comma 0 comma 2. And we're going to get 38.536 or 38.537. 2 pi math 9 x times the square root of x comma 0 comma 2 plus 2 pi math 9 x parentheses square root of x minus x plus 2. I distribute the negative, so I have to put extra parentheses in there. Close those parentheses, comma x, comma 2, comma 4. See if we get the same answer. Same answer for both, 38.536, 38.537. They're not exactly the same. Right here at the 7th decimal place, they start changing, but that's fine for us. So 38.536. We'll write our setups in here. Volume equals pi 0 to 2 x plus 2 squared dx minus pi 0 to 2 of x to the 4th dx. Volume equals 2 pi 0 to 2 y square root of y dy plus 2 pi 2 to 4 y square root of y minus y plus 2 dy. There we go. Setups. Yeah, 2 pictures would have been helpful on this one, I think. All right. Just see some other random stuff that we've done on, I feel like, other, units. Given y equals g, y equals fx, the areas and the closed regions, find the areas. So if you want to find the area between all of these, okay, you want to make sure you do top minus bottom, right? So for g, I guess we're actually just finding the numbers, right? Okay. So if we just integrate g, that could be negative. So g is this guy, so it's going to be 3 plus negative 7 is negative 4. And f is going to be negative 2 plus 4 is 2. So those aren't areas. G minus f of x, well, for this first one, it's going to be 3 minus negative 2, because g is positive and that one's negative, minus, or plus, okay, and that's it. That's 0 to 4, so that answer is going to be 5. Now g minus f for the whole thing, well, you're going to get 3 minus negative 2 for the first chunk. And the next chunk, g is down here, so it's going to be negative 7 minus positive 4. So it's going to be 5 minus 11 is negative 6. And then the absolute value of g minus f, well, that's just going to give you the area between them, and it's going to force it to be positive. So it's going to be 16. So a little bit of a integral, definite integral stuff. All right, this one, you're given the graph of f prime and given a value at 2. Oh, yeah, we've done these a lot, right? Fundamental theorem of calculus part 1. If you integrate f prime, you're going to get f. That's a basic, easy, really important idea, but very simple idea in calculus. And that's what we're using right here. Now, if I know 2 and I want 8, I'm going to do smallest to biggest, and then I'm going to plug limits in like I would if I were integrating by hand. And this is what I want. So now I'm going to solve for f of 8 by adding this to the other side. I'm just flipping the sides for convenience. This is all important work to show. So you can follow your work now. F of 2 is 7, right? And then 2 to 8 is going to be all this area right here. Now, this right here is 4. So this is definitely 2 and 2. This is the radius of this, and this is just a quarter of a circle. And it's going to be negative because it's below. And then you have a trapezoid here, and that's going to be 4, and that's going to be 3, and the height is 3. So the area of this trapezoid would be average of the bases, 3 plus 4 divided by 2 times the height. And this guy is going to be 1/4 of pi r squared. So it's going to be negative, though. So that's going to be 7. That's going to be what? 21 halves. 21 halves minus pi. So f of 8 is going to equal 1435 halves minus pi. Fundamental theorem of calculus part 1. All right, that's some good practice. You just got to get really good at drawing, all these drawings and stuff, and understand the geometry of it. You shouldn't be memorizing really any formulas this chapter. If you are, it's not going to go well. Just let me know.